Good evening, children. Good evening, online students.
Good evening, ma'am.
Good evening.
Good evening, ma'am.
Good evening. Completed the assignment, children, given in the last class?
Yes, ma'am.
Yes, ma'am.
Okay, Harsha, yes. Shreya, yes. What about Aishwarya, Anantika,
I
Gayatri?
had some technical issues. I could hear you now only. Did you guys do anything?
Yeah. Have you completed the assignment, Aishwarya?
The assignments to find the square root, right, ma'am?
Yeah.
Yes, ma'am, that is done.
Okay, Anantika? Gayatri, yes. All right. Yeah, what about you? You could try it? You had time? No. No problem. Finished. Okay, you tried. Okay. Good evening, Ariston.
Good evening, ma'am. Yeah,
Good
I just
evening.
joined the class.
Yeah, we're just about to start. Yeah. Yeah. Yes, Gayatri. What is the square root of the first number? All of you open your assignment. Check your answers. Yes, Gayatri. What is square root of 4356?
Hi, ma'am. Ma'am, this is
Yeah.
Anantika. I did the homework.
You completed? Okay, good. Okay, Anantika. I asked Gayatri, but I'm not able to hear from her. Why don't you tell us? Tell me the prime factorization of 4356. Quickly read from your book. Okay, Lakshana. No, just tell me the 4356 is equal to. No, 2 into. Read the prime factors from there. 2 into 2 into 11. Into 11. Okay. Okay. Why no response from the online students?
Ma'am, may
So what
I?
is
Yes, ma'am, I got it right.
Having some internet problem, but I have done the like the homework that you have given.
Yeah, Anantika, I was actually I wanted to ask you. Recently, I don't see participation from your end, so I just assume that you must be having some internet issues. But is it that?
Yes, ma'am. But otherwise, whenever you ask questions, I am always answering.
Okay. All right.
Ma'am, may I
So,
answer?
yeah, who's that?
Harsha, ma'am.
Harsha. Yes, Harsha. So what's the square root of 4356?
66.
66.
Yes, ma'am.
Yeah. Check all of you. The long division. Check.
Got it right, ma'am.
Yeah, very good. All of you check the long division.
Yes, ma'am, same here.
And the prime fact. Yeah, check the prime factors and the long division method. Right? I'll share the answers, Yarni. I'll share the answers. You don't have to write anything. I'll share the answers, okay? You got this right? Yes. Okay, good. What about the long division method? We divided. Yeah. And I found the answer 66. You got it right? Okay, very good. Yeah. What's the square root of 2304, children?
Ma'am, can I answer?
Yes.
Ma'am, can I
It's
say?
Yeah, chorus. Answer.
2 into 2 into 3 into 3 into 2 into 2 into 2 into 2 into 2 into 2.
No, you must, in that case, you can tell me in the exponential form.
Okay.
2 raised to the power?
2 raised to the power 3. 2 into 3 into 2 to the power raised.
Ma'am, 2 to the power 9 and 3 to the power 2.
No, you cannot have 2 to the power 9. You cannot have odd number of equal primes.
Actually, I have six twos, ma'am. 6 twos which I
Yes, 6
What is the
Which
square
I-
root? What is the square root?
48, ma'am.
48, ma'am.
48. It's not 2 to
Yeah.
the power 9, Anantika. It is 2 to the power 8.
Ah, okay. I must have counted it wrong then.
Then how did you get 48? Oh, you counted it incorrectly.
Yeah.
Ah, okay, I get you. Okay,
Like,
fine.
there's so many
check your
twos.
answer. Check your answers, all of you. Got the same prime factors? Very good. What about the long division? Children, any doubts you can ask me? I'll share all these slides on WhatsApp, but online students, have the option of taking a screenshot also. I will be sharing these answers. I will be sharing these answers on WhatsApp with you. For the sake of the students who attend the physical class, they cannot take a screenshot now. So I will be sharing the answers on WhatsApp, but online students, you can take it now if you want. So I don't have to mention that every time. Whenever you want a screenshot, you can just take it. Any questions here?
No, ma'am.
All right.
No, ma'am.
All right. Yeah, Lakshana, what is it?
2 into 2.
No, tell me the square root first.
198.
198. Okay, how many twos? Count and tell me how many twos.
There are 2 2s and 4 3s and 2 11.
2 twos, 4 threes, and 2. Very good. Very good. Yes,
Got it right, ma'am.
very good.
We get 2 into 3 into 3 into 7 into 1.
Only 111. When you bring it out of this, yeah, because from 2 11s, only 111 will come out. Lakshana? Correct? Any questions, online students?
No, ma'am.
No, ma'am.
Okay. Ariston? Have you completed the assignment, Ariston?
Yes, ma'am. I'm done with like 6 questions. I have 4 questions remaining.
Oh, I like that honesty. So nice of you. Very good. Okay. Okay, you can complete it later, but for the 6 which you have worked, please check the answers. The first 6 you have done, right?
Yes, ma'am.
Very good. Okay, please check the answers. Have you got it right so far?
Yes, ma'am. So far, I got it right. I'm waiting for the next one.
Okay, very nice. Very nice. Okay. Yeah, Ariston, what is the square root of this number?
Ma'am, it's 5 3s and 3 7s when, yeah.
5
It's like-
threes. That's not possible. 5 threes is not possible.
No, like it's 3 raised to the power 5 and 7 raised to the power 3.
No, darling, you cannot get, odd number of equal primes.
Okay.
Yeah. Okay, what is the square root you've got?
Ma'am, once again, I got it like. One second, I'll tell you. I just wrote it in a. Yeah, I got it as. Oh,
No, time up, time up. Okay.
yeah,
So
I'll
it's this. Is it 189? 189? Okay.
Yeah, ma'am, I have written somewhere, but I have to write it neat.
No, you have to write it neatly. Only then you can, we can discuss the answers in the class. Why somewhere you wrote it? Yeah.
Yes, ma'am, I got it as 198. I wrote it in the top left corner.
Okay. Aishwarya?
Yes, ma'am, I'm there.
Yeah, no. Is it right? Have you got the same answer?
Yes, ma'am, I got 1892.
Okay. Harsha, Gayatri, Anantika.
I got the
Yes,
same
ma'am.
answer.
I also have got.
Got the right answer, ma'am.
Shreya, yeah, okay, very good. Okay. Okay. Okay, over to the next one. Yeah. What's the square root of this number?
252.
250?
No.
No, not possible. 252. 2 twos are 4. This one ends with 5.
Ma'am, 225.
225. Okay,
Ma'am,
225.
225 here. Same.
225. Yeah, 225. Check your prime factors. So we need to perform this procedure first. We need to perform this procedure first. And then, excuse me, using this, we express 50,625 as 3 square into 3 square into 5 square into 5 square. We need to do this one first. Which one? We need to work this one first. So using this procedure, we can express 50,625 as, that is 50,625 is equal to 3 square into 3 square into 5 square into 5 square. That's what you see here. After that, you will have to take square root on both the sides. See, presentation is very important. Your answer may be right, but you need to also present it correctly. So this is the first step. Then you need to take square root on both the sides. Taking square root on both the sides is the next step. I told you that you will have to repeat the step. Write the same thing again. Repeat the step and take square root on both the sides. That is the second step. You need to write the step again. And then take square root on both the sides. That is the second step. In the third step, you need to write this as it is. Square root of 50,625 as it is. Now here, we need to get rid of the square root symbol. We need to get rid of the square root symbol. So for that, what we do is from 2 3s, we bring 1 3 out. From these 2 3s, 1 3 out. From 2 5s, 1 5 out. From 2 5s, 1 5 out. And now see here, you shouldn't put the square root symbol here. This is how the square root symbol is eliminated. From a pair meaning from 2. From a pair of equal factors, we bring 1 out. And we get rid of the square root symbol. So the square root of 50,625 is equal to the product of these numbers. 5 5s are 25, 25 9s are 225. Long division method, understood clearly, children? Long division method? Okay. Online students have shared the video also. Long division method, any issues, please watch the video and try it correctly. Any questions here, children?
No, ma'am.
No, ma'am.
Very good. Yeah. This one?
Ma'am, can I try?
Yes.
Ma'am, I got the square root as 161.
161. Is it right? 161. Very good. You're
Yeah.
right.
Yes, ma'am. I also got 161 from both the
Very good.
methods.
Very good. Very good, Anantika and Ariston. Ariston, read out the prime factors.
Ma'am, it's 7 squared plus 23. I mean, yeah, 23 into 7. Like I got like 7, 2 7s and 2 23s.
Is that right? 2 7s and 2 23s. Perfect. Very good. So sometimes the number, is not divisible by, see, you need to take the prime factors in order. You need to first check if it's divisible by 2, then by 3, then by 5, then 7, 11. You should not use 9. 9 is not a prime number. 9 is not a prime number. You should not use 9 to divide here. Because 9 is not a prime number. So then after, if 11 does not work, you'll have to take 13. If it's not divisible by 13, then no, 15 is not a prime number. 17. Then if it's not divisible by 17, then 19. Then no, 21 is not a prime number. 23. 21 is not a prime number because what are the factors of 21? What are the, how many factors does 21 have, children, online children?
Ma'am, 3.
No.
3, 7.
1 is a factor of every number. I did not ask prime factors. Okay, let me make it clear. My question was not the prime factor. Even if it was prime factors, you can say only 2, 3 and 7. My question was how many factors? So the answer is 4 because the factors of 21 are 1, 3, 7 and the number 21 itself. These are the factors of 21. 1, 3, 7 and 21 itself are the factors. The prime factors of 21 are 3 and 7. The prime factors. Only the prime factors. Prime factors of 21 are 3 and 7. The factors of 21 are 1, 3, 7 and 21. Where 1 is not a prime number, 21 is not a prime number. 3 and 7 are prime numbers. Okay. So in this division here, you need to use only prime numbers. Only prime numbers. Okay. So see here, everywhere same step, children. Write this one, then write this step again and take square root on both the sides. Then from 2 7s, 1 7 out of the square root. From 2 23s, 123 out of the square root. And 2 into 23 is 121. Yeah, check the long division.
Got it right, ma'am.
Very good. All of you please acknowledge online students. You got it right? What about you? All right, fine. Yeah, please check. So this number is not divisible by 2. It's not divisible by 3. It's not divisible by 5. It's not divisible by 7. So you should not get tired. If it is not divisible by 2, it will not be divisible by 4. Yeah, it will not be divisible by 4. So what you can do here, no? You can find out the, see, when supposing you have to find the, supposing you'll have to find the square root of this number by the prime factorization method. So you're like trying 2, 3, 5, 7, it's not working. So what you should do, immediately find the square root of this number by the long division method. Long division method, you will get it easily. And then you will notice that the square root is 41, where 41 itself is a prime number. And then you should put it here. So if you're not able to find the prime factor of 1681, no worries at all. Don't take 10-15 minutes to think about which number, by which number it is divisible by. Don't spend time. Simply find the square root of that number by the long division method. That you will get easily. So find the square root. So if you're not able to find this factor, then proceed to find the square root of that number by the long division method. And then you will find the square root here, 41. So you know 41 itself is a prime number. So you'll have to use that straight away here. 41 times 41 once. And also you can see, given that, supposing I tell you that 1681 is a perfect square, okay? I tell you that 1681 is a perfect square. You can even guess. You can even guess the square root. I'll tell you how. But it should be given that the number is a perfect square. Only then you can guess. Not for any number. If I give you a number which is a perfect square, I tell you that this number is a perfect square, then you can guess its square root easily. You need to just find the range in which the number lies. Now this number 1600. See, now we have understood these two methods, children. I'm just telling you something else now. The question here is to find the square root of this number by the prime factorization method and the long division method, and we are done with it. This is something apart from the answer here. If you're asked to find the square root of if you're asked to guess the square root of 1681, and I tell you that it is a perfect square. So what you need to do is, now this number lies between 40 into 40, which is 1600, and 50 into 50, which is 2500. Find the range in which the number lies. You cannot do it is you cannot see, you should find the two perfect square numbers between which it lies. You need to find the two perfect square numbers between which this number lies. So 40, so in that sense, so it's like 10 into 10, 1 into 1, 1, 10 into 10, 100, 20 into 20, 400, 30 into 30, 900, 40 into 40, 1600, 50 into 50, 2500, 60 into 60, 3600, and so on. Okay, 70 into 70, 4900, because 7 7s are 49, and then the 2 zeros. So like this. Now we know that the given number 1681 lies between 1600. It lies between 1600 and 2500. Correct? Now what is this? This is 40 square. And what about this one? 50 square. Now the numbers between 40 and 50 are 41, 42. So this number can be 41 into 41 or 42 into 42 or 42. One, I haven't finished, just wait for me to finish. Or it can be 43 into 43 or 44 into 44, so on till 49 into 49. Okay, now since the number ends with a digit 1, it ends with a digit 1, it can be only 41 into 41 or 49 into 49, because 9 nines are produces 81. 1 in the, see, forget 8. Forget 8. 9 nines are 81, which means you will have 1 in the units place. Because when you start the division, what will you do? 9 nines are 81, 1 8 carried over. And under this, you will not get anything, no? You will put a 0 or you will put an into only, right? So you will get that 1 down as it is. Yes or no? When you multiply, when you find this product 49 into 49, 9 nines are 81, 1, 8 carried over, and then you do the multiplication. And below this 1, you will have whatever you do, 0 or into. So this 1 is going to come down as it is, right? So which means 49 into 49, the product of 49 and 49 is something which has 1 in the units place. The product of 41 and 41 is also something which has 1 in the units place.
I mean, if this number ended with 2 means?
No number ending with 2 can be a perfect square. A number ending with 2 cannot be a perfect square. 2, 3, all these numbers cannot be a perfect square. I'll come to that. Yeah, nice question, but I'll come to that. Okay. So, all right, children. So now, so it has to be 41 into 41 or 49 into 49. Now, if it was 49 into 49, 49, 7 is a multiple of 49. Then this number should have been divisible by 7, right? But it was not divisible by 7. So it is 41 into 41 only. It is 41 square. See, you tried to find the prime factors of 1681. It was not divisible by 7. Then how can it be 49 into 49? Because 7 is a multiple of 49, right? Then it should have been divisible by 7. It was not. So that means it is 41 into 41. So now this one, to explain, I'm taking this long, but your mind will do it in 10-20 seconds. You will not take this long to guess this answer. You will see the number like this. It is between these two. Then you will think of 41, 42, 43 and all that. Then it ends with 1. So it is 41 or 49. But 49 not possible because 7 is a multiple of 49. So it's 41. That's it. You can process it faster. So this you can apply it to any numbers. Any number given that the number is a perfect square. Am I clear, children? Online students? Am I clear?
Yes, ma'am.
Yes, ma'am.
Yeah. Now we'll just see the digits with which perfect squares can end. Okay, now see here, 1 into 1, 1, 2 2s are 4, 3 3s are 9, 4 4s are 16, 5 5s are 25, 6 6 are 36, 7 7s are 49, 8 8s are 64, 9 9s are 81, 10 10s are 100. So a perfect square can end with the digit 0, 1, 2. You cannot see here. You cannot see 2 here. You cannot see 3. It can end with 0. It can end with 1. It can end with. Can you see 2? No. 3? No. 4? Yes. 5? Yes. 6? Yes. 7? You don't see 7 there. It can't end with 7. 8? Can you see 8 there? 9? And 0. So what are the missing digits? 0, 1. So 2, 3. 4, 5 is here. 4, 5 is here. 6 is also there. So 7, 8, 9 is here. So if you come across a number that has 2, 3, 7 or 8 in the ones place, in the units place, it is not a perfect square. It cannot be a perfect square. Any number ending with a digit or having these digits in the ones place or the units place cannot be a perfect square. A number ending with 2 or 3 or 7 or 8 cannot be a perfect square. Numbers that end with 0, 1, 4, 5, 6 or 9 may be a perfect square. Need not always be a perfect square. You cannot say that every number that ends with 4 is a perfect square. Then in that case here, there are so many numbers that end with 4. 4, 14, 24, 34, 44, 54. You think all these are perfect squares? No. Perfect squares can end with these digits, but that doesn't mean that every number that ends with these digits is a perfect square. Every number that ends with 0, every number that ends with 1, every number that ends with 4, every number that ends with 5, 6 or 9 is a perfect square, is false. If the number is a perfect square, then it can have one of these digits in the units place. If the number is a perfect square, then that number can have only one of these digits in the ones place. If a number is said to be a perfect square, then it can have only one of these digits in the ones place. If a number ends with any of these digits, it is not a perfect square. You don't have to find the square root at all. It is not a perfect square. But if it ends with one of these digits, it may be a perfect square. It may be. You can't say it is a perfect square. It may be a perfect square. Because 25 ends with 5, it is a perfect square. But 35 ends with 5. It's not a perfect square. 45 also ends with 5. It's not a perfect square. 225 ends with 5. It is a perfect square. 15 square is 225. So like that. 625 ends with 5. It is a perfect square. 25 squared is 625. So just remember 2, 3, 7, 8. They're consecutive numbers. 2, 3, 7, 8. 2, 3, 7, 8. Now you are in which standard? Now you're on 8th standard. So last year you were in 7th standard. Yeah, so 2, 3, 7, 8. Easy to remember. It's very simple. It's easy to remember this. Now you're in 8th standard. So last year you were in 7th standard. 2nd standard, 3rd standard. 2nd standard, 3rd standard, 7th standard, 8th standard. 2, 3, 7, 8. Or if 23 happens to be your birthday, or you can relate any other event or something to 2, 3. So it's easy to remember. The rest of the digits may be a perfect square. Again, the other thing is, so 2, 3, 7, 8, not a perfect square. Units place. Units place. Not a perfect square. Not a perfect square. But if the units place has, 0, 1, 4, 5, 6, 9, may be a perfect square. Maybe a perfect square. All right. Now, if the number ends with 0 and is a perfect square, okay, a number ending with odd number of zeros cannot be a perfect square. A number ending with odd number of zeros. Now, for example, 5, 1, 2, 3. It ends with 0, but it has odd number of zeros. This also cannot be a perfect square. Why? Because see now when we multiply 20 with itself, you'll get 4 and 2 zeros. Because you'll have a 0 here and a 0 here. So you'll get 2 zeros. Or if you multiply 200 and 200, you will get 2 to the 4 followed by 4 zeros. So this product cannot give you 3 zeros. So if the number is a perfect square, then it will have even number of, it will end with even number of zeros. It will end with even number of zeros. Just a second, children. All right. So we'll continue discussing the answers, children. No. Yeah. Square root of this one. What is the square root of this number, children?
343.
3, 4, 3.
343, ma'am.
Yeah, so you can see 3, 4, 3. 3, 4, 3. Can you see that? It ends with 3. 3 3s are 9. Or maybe, see, it can be 3, 4, 7. 7 7s are 49. 3 3s are 9, 7 7s are 49. So you can see here, 3, it ends with 3. Only then you'll get 3 3s are 9 in the ones place. Very good. So you have 6 7s. $343. Please check the prime factors, children. 6 7s. Correct, Lakshya? Lakshana or Lakshana? Lakshana, correct? 3 7s, yeah. From 2 7s, 1 7 will come out. Okay. What about this? 1? 231. Is that right, children? 231? Online students?
Yes.
Yes, ma'am.
231. Very good. Please check.
Yes, ma'am.
It's correct, ma'am.
Ma'am, same answer, 231.
Very good, very good. Yeah, this one. 361.
Yes, ma'am.
361.
361.
Very good, Shivu. All right.
Yes, ma'am, same, 361.
So here also you would have tried with 2, 3, 5, 7, nothing worked. You'll have to hit 19 straight away. So if it's difficult, even if the question is find the square root by prime factorization method, you can do the long division method in the rough column to get the number. You can do it in the rough column. So you get 361. Again, you're not getting any clue. 361, you cannot put 361 straight away here. 361, you don't know if it's a prime number, right? See, children, supposing the question is find the square root of this number by the prime factorization method, and we are not able to find out by which prime number this number is divisible by, because we tried 2, 3, 5, 7, nothing is working, and you don't know. So then you remember, okay, let me find out the square root by the long division method, and you find out the square root by the long division method, and you're getting 361. Okay, 361, you cannot put 361 here. Because 361, we don't know if it's a perfect, we don't know if it is a prime number. So you cannot put 361 there. Then what to do? So what you do, you find the square root of 361. You find the square root of 361. Find the square root of 361. So it will be, how will you pair this? 6, 1 and 3 stands alone. Find the square root of 361 to get the number. Find the square root of 361. 6, 1 and 3 stands alone. 1 ones are 1. Okay, you can see the board. 1 ones are 1. 2 is a remainder. The next pair comes down. Double the quotient. Whatever digit you place here, you must place the same digit here. This is the last stage of division. You can see it ends with 1 here. So it has to be 1 and 1, or it has to be 9 and 9. Because 9 nines are only 81. This is the last stage of division. So you can place a 9 with, because 9 nines are 81. Or you can place 1. 21 into 1 is 21. So it's 9 nines are. 9 nines are 81, 1 8 carried over, 9 twos are 18, plus 8, 26 and 0. So 19. So 19. Now you can use the 19 here. It's 19. So if this number is not helping you, find the square root of that number. That will definitely give you the required number. All right. Okay, so before we proceed, we're going to take up a small test. Yes, quickly. Take down the question and answer it, children. All of you take down the question and answer it. And if you get it, you can share your answer. If you finish working, please share your answer.
Ma'am, I got the answer is 56.25.
Yeah, you're right. No. Surya, it is find the value of 7. Okay. How will you find the value of Surya? How will you find the value of?
Mom, I got 66.25.
Yeah.
You can square it.
What? No. What will you do? If it is 2 square, how will you work it?
Ma'am, 2 into 2. You multiply that number twice with itself. Like.
Yeah, very good, Anantika. So it is 7.5 into 7.5. What are you doing? Take it your hand.
No, I just started to.
No. Okay, so don't do that. Yeah. So you take a smaller number and understand the question better. So this is 7.5 the whole square. So assuming that, we don't understand this. Just take a smaller number. What would you do if it is 3 square? What will you do? 3 into 3, 9. So this will be 7.5 into 7.5. 7.5 into 7.5. So this is a simple question, children. 7.5. Yeah, 7.5 the whole square, which means 7.5 into 7.5. 7.5 multiplied with itself. Next one. Yeah, I'll take it. So you should find the square root of the numerator separately and the square root of the denominator separately. Okay? Yeah.
I got the numerator is 11 and the denominator is 13.
So what's the answer?
11 upon 13.
Yeah, 11 upon 13. Yeah. So here you don't have to show, much of working or calculation here. I'll tell you. See here. So square root of what is the 121? We know it is 11 into 11, correct? 121 we know is 11 into 11. And 169 we know is 13 into 13. Otherwise we have to find. Supposing, say we don't know, then you have to do this. 11, 11s are 11 ones are. Similarly 169. 13, 13s are 13 ones are. So 121 is, so see here children, you need to put the square root symbol. See there is square root here, so you need to put the square root symbol and write 121 as 11 into 11. 121 is 11 into 11 and 169 is 13 into 13. Now from 2 11s, 1 11 comes out of the square root. From 2 13s, 1 13 out of the square root and hence the answer is 11 by 13. To start off, you should put the square root symbol. You must put the square root symbol and write 121 as 11 into 11. Write 169 as 13 into 13. Then from 2 11s, 1 11 out of the square root. So don't put the square root in the next step. From 2 13s, 1 13 out of the square root. So the answer is 11 by 13.
Ma'am,
Okay.
I've done the exact way that you have showed the solution.
Very good. Done all of you? Finish working? Yarni?
Done, ma'am.
Okay. This is your next question. Find the square root of 10,404 using the prime factorization method. Using the prime factorization method.
Ma'am, I got the answer, ma'am.
Yes, Shreya, what's your answer?
It's
Tell me the
100
prime factors. Tell me the prime factors of 10404.
So it's 2 into 2 into 3 into 3 into 17 into 7. Which
2 square into 3 square into
17 square. The answer is 102, ma'am.
very good, Shreya.
Yes, ma'am, I got the same thing. Only thing I did it a bit slow.
Good, good, good. Hmm. Got it?
Yes, ma'am, done.
Very good. Yarni? Okay. Any questions, Yarni? Okay.
Ma'am, next question.
Yeah, yeah. I'm just waiting for the others to finish here in the class. Done, children? No, you should not write LCM is equal to. No, exactly what you see on the screen. 10,404 is equal to. See, if you write LCM means you should have at least two numbers, no? For one number, you cannot find the LCM. LCM means you must have two or more numbers. So it doesn't make any, it's not meaningful to write LCM is equal to. Yeah. I think it finished that, right, Surya? Yes, children. Find the square root of 2,36,196 using the long division method. Using the long division method. You can take the table closer to you, girls. If it is away, take it closer to you. I'll do it again. Yeah. Four, 8, 6. 4, 8, 6. What about you? Online students? Very good. Lakshmi, you're right. 4, 8, 6. Lakshmi has already got the correct answer. 4, 8, 6. Okay, let's understand the long division, the procedure to find the, let us understand the procedure to find the square root of a perfect square using the long division method. Again, let's see that method again. So place the number like this. Group the digits from behind. So 9, 6 makes a pair. 6, 1 makes a pair. 2, 3 makes a pair. Now we need to start off with the number 23. 23. Now 4 into 4 is 16. 5 into 5 is 25. So the thing is, you need to get 23 or a number just less than 23. So it is 4 4s are 16, right? You cannot use a regular tables. You'll have to use a square tables, like 1 into 1 is 1, 2 into 2 is 4, 3 into 3 9, 4 into 4 16, 5 into 5 25, and so on. So between these two numbers, this is the closest, right? So 4 4s are 16. See, we're writing all the digits. We're using this one, right? 4 into 4 is 16. 4 4s are 16. We're writing all the three numbers which are here. 4 4s are 16. Then as always, we subtract. So when you subtract, you get 7. After subtracting, bring the next pair down. Next step, double the quotient. The quotient is 4. Double it, 8. Sorry. Correct. Double it, 8. Now, whatever digit you place here, you must place the same digit here. Now, supposing you place a 6 here, you should place a 6 here also. Then how will you find the product? The product is 86 into 6, not 46. It's 86 into 6, not 46. So let us try. So again, our intention is to get 761 or a number just less than 761. So let us try 86 into 6. So 6 6 are 36, 3 carried over, 6 8 are 48, 49, 50, 51. No, 516, it's very less. So 6, we'll jump 7 because 516, right? So we'll jump 7, we'll try 8. So if you place 8 here, if you place a digit 8 here, you must place the same digit 8 here. And what should you find? Multiply 88 into 8. So 8 8 is 64. 6 carried over. 8 8 is 64 plus 6 70. 70. You try if you want. I mean, meaning if we want, we can try this. But you will see that 704 is the number.
Yes.
To 761. This number will be greater. Correct? Yeah. So 88 into 8 is 704. And the remainder is 57. Bring the next pair down. Double the quotient. 48 into 2. Double it is 96. Place that here. Place 96 here. And again, whatever digit you want to place here, you must place the same digit here. And we see that this is the last stage of division. This is the last stage or the final stage of division. So now this number here, 5796, ends with the digit 6. So we can use 4 because 4 4s are 16, which gives us 6, or 6 6 are 36, which gives us 6 in the ones place. So try one of the two. But since you told me the answer it is 486, I'm going to go with 6. You try 4, okay? When you try now in the last stage, we know that the given number is a perfect square. See, we know that the given number is a perfect square. So you want the product to be exactly 5796. You are not going to settle for anything less than 5796. You want the number 5796 exactly. So you try now. So you can try 4 here. You can try with the 4 here. If that doesn't work, you have to try 6. Correct? Only one of the two, because only that will give you a 6 in the ones place. So 6. Now how will you multiply? It will be 966 into 6. 966 into 6. Every time here you will have only a single digit. Every time here you'll have only a single digit. Now when you multiply 6 6 are 36, 6 3 carried over. 6 6 are 36 plus 3 39, 9 3 carried over. 6 9 are 54 plus 3 57. So exactly 5796 and the remainder is 0. So the given number is a perfect square because the remainder is 0. The given number is a perfect square and the square root of the number is 486. The square root of the number is 486. Is it okay now? Very good. Shreya, all of you online? Got it?
Yeah, ma'am. Understood.
Understood, ma'am.
Aishwarya, got it?
Yes, ma'am, I said I got the same answer.
Okay, very good. Okay, Ariston, Gayatri, Harsha.
Got it, ma'am.
Yes, ma'am, got it the same answer.
Okay. So Yarni, I'll share the answers so you can complete it later. Okay. Yeah, there's the next question.
We need to find the square and we need to subtract it.
Yeah.
Ma'am, -1.
Very good. Minus
Yes,
1.
same answer.
Minus 1.
And I got the same answer.
Very good. So what is the square root of 25? 5.
5.
And the square root of 36? 6.
6.
5 minus 6 is -1. Very good. Sorry. Done?
Yes, ma'am, done.
Done, ma'am.
Okay. Very nice. There's the next one.
7.
Exactly, ma'am. 7.
See, that's what it is. Be careful. Read the question carefully. Simple questions are always deceiving.
Ma'am, 2401.
Yeah.
Oh my god. I got the same answer, ma'am.
What you got 7, is it?
No, ma'am, I got 2401.
Yeah, that's right. See, it's, like things which are very humble. Now, when you consider food also, very simple food like millets, many things you can mention, guava, apples, some certain things which look very simple are packed with nutrients. But fruits which are very rare, like blueberries or raspberries or strawberries or this and that, they may not be as good to the body as the other simple fruits like guava and pineapples and all that. So humble things are always rich. So like that, this question is very humble. The square of 49 is, and we underestimated it. We underestimated the question. The square of 49 is 7. No, it's 49 into 49, which is 2401. Correct? So please read the question carefully, children.
Yes, ma'am.
The question is the square root of 49 is 7.
Answer is 2004.
Yeah, correct. The correct answer is 2401. If the question was the square root of 49 is, then it is 7. The square of 49 is 49 into 49. The square of 49 means 49 square, which is 49 into 49, which is 2401. The square root of 49 is 7. Are you writing everything, Arnie? Okay. What is this one?
This is 7, ma'am.
This is 7. The square root of 49 is 7. Done? Yeah. The question is express 12,100 as a product of its prime factors. Express it as a product of its prime factors. Don't find the square root or whatever. Simply express it as a product of its prime factors. Now, for example, how will you express 35 as a product of its prime factors? 35. 5 7s are 7 1s are. So 35 is equal to 5 into 7. That's all. Like that. Express it as a product of its prime factors. No square root or anything.
Mom, I got the answer.
Same, ma'am.
Yes, Aishwarya, tell us.
Mom, 10 into 10 into 11 into 11.
No, 10 is not a prime number. As a product of its prime factors.
Oh, yes, Mom. One second.
Ma'am, I got the answer.
Yes, Shreya?
It's 2 square into 5 square into 11 square.
Perfect. It's 2 square into 5 square into 11 square.
Mom, same.
Good.
But first I used 11, then I went to 2, then 5.
Yeah, but I don't know. I have this because my teacher told me start with 2 always, then try 3, then 5, then 7. So I still, remember what she told me when I was young. So I follow that. I never start. I never write. I never try 5, then 2, and then 11. No. I like it to be organized. So you're not wrong. You're not wrong. You will get full marks for what you've done. But I normally follow a pattern like this. I start with 2, then I try 3, then 5, then yeah, like that. So here the question is simply express the number as a product of its prime factors. That's all. No square root or anything. Simply write this and leave it. Just because we know how to find the square root of this number, you should not write all that. We need to answer the question. That's it. See, you've written square root, I think. Okay, I'm sorry, I think. For the last line, Now I can see the square root symbol in your book. Last line.
So that's
Sorry? Sure. You don't have to take my permission for that. You can go ahead.
Ma'am, I
Yeah.
think the answer is xy raised to the power 6 and z raised to the power 8.
No. Come again. X.
Ma'am, xy raised to the power 6 and z raised to the power 8.
No.
Sorry, x raised to the power 2, y raised to the power 6 and z raised to the power 8. I forgot the 2.
What's your answer? Very good. Okay. Yeah. So
Ma'am, the questions are so simple, but somehow something
we tend to go
goes
wrong. Yeah. That's what.
Ma'am, I don't
Question?
understand this question, ma'am.
No. Yeah. We'll do it. Yeah. So like when it is okay, now what is a b the whole square? What's the meaning of a b the whole square? We need to multiply a b with itself. So a into a is a square and b into b is b square. So a square b square is the answer or the product. So similarly here it is xy cube z to the power 4 into xy cube z to the power 4. We need to multiply the same expression with itself. We need to multiply this expression with itself like this.
Oh, okay, ma'am. I understand it now.
This is x to the power 1. And I can give you one more step. So this is equal to x into x into y cubed into y cubed into z to the power 4 into z to the power 4. So when base are same and its multiplication, we add the powers. Is it okay now? All of you?
Clear, ma'am.
Okay.
Ma'am, but I didn't do like how you had done. I just multiplied like x2 and then like 2 3s are 6 and 2 4s are 8.
Yeah, this step and the last step is enough. This one and the last step is enough. But
Okay.
it's not, these are not extra steps kind of. You can present it like this. But you will also get marks if you simply present the first and the last step. Yeah, exponents, you have some idea? When bases are same and its multiplication, we add the powers. Learned some of it in 7th standard. Yeah. X into x. When bases are same and its multiplication, we add the powers. Okay. Any questions here, children? Online students? Okay. Okay. Yeah. This is the next one. So for questions like this, it's not that you should express 36 as a product of its prime factors here. When the question is find the square root of a number using the prime factorization method, then you should use only prime numbers. So here there is no specification like that. You can use numbers that are not prime also. Here. Like 36, you can directly write 6 into 6. Because there's no mention.
Ma'am, I'm not sure of the answer, but is it 6a raised to the power 8b raised to the power 6 and c raised to the power 4?
No. Try again. Think again.
I also thought of saying the same.
6, a to the power 8, b to the power 6, and c to the power 4, is it?
Yeah.
Yeah, ma'am.
No, no. Shri also? No, 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 no.
Mom, is it like possible that A is the cube or something?
No, no. Again, a very humble question.
Ma'am, is it
Oh.
6?
By
Is
mistake,
it
I went to
6 a
Is
to
it?
the power 4? Is it 6 a to the power 4, b to the power 3, and c to the power 2?
Perfect. Yes. So I told you, children, in questions like this, you don't have to write 36 as the product of its primes. Only when the question is use the prime factorization method to find the square root. Only when that mention is there, you'll have to use prime numbers. Otherwise, you can write 36 in any way you want. So 36 is 6 into 6. A to the power 8 is a to the power 4 into a to the power 4. B to the power 6. B cubed into b cubed. This one is c squared into c squared. When you practice like this, you will be able to handle still complicated ones. It's all practice. You're seeing it for the first time, right? So it looks like it is whatever. But with time and practice, you will get used to all this. So 36 is 6 into 6. So here you can see a 4 plus 4 is 8. This one is a to the power 8. This one is b to the power 6. This one is c to the power 4. Take half of it. 8. Half of 8 is 4. So 4 and 4. Half of 6 is 3 and 3. Half of 4 is 2 and 2. See, using the law of exponents, this product is a to the power 8 because 4 plus 4 is 8. This product is b to the power 6 and this product is c to the power 4. So now from 2 equals, we bring 1 out. 2, 6, 1, 6 out. A to the power 4, 1 out. B cubed, 1 out of the square root and c squared, 1 out of the square root. And the answer is 6 a to the power 4, b cubed, c square. Done? Okay. Any questions? Okay. I'll let you know. Made a note of it, all of you?
Done, ma'am.
Surya, if you don't mind, on the first switch on it. In fact, எல்லாத்தையுமே அனுப்பிச்சிடும் அந்த ஏசி சுவிட்ச் தவிர எல்லாம் அனுப்பிச்சிடும் எல்லாம் அனுப்பிச்சிடும் Yeah, thank you. Yeah, this is homework, children. Okay, I'll share the picture. 1 minute.
Mom, you have to do this right now.
No. Homework. Not now. 1 second.
Okay.
Yeah, I've shared the questions on WhatsApp. This homework. Somebody's mic is enabled. Please disable your mic. Yeah. Yes, sure. Now this is class work. Take down this question. Find the square root of 75.69. Find the square root of 75.69. Give the heading, find the square root of the following. The first one is 75.69. Okay. So we'll do it by the, I think here I have only, okay, I've done both. Okay. So I've done it using both the methods, the prime factorization method and the long division method. Let's do the long division method together. Listen to this carefully, children. This is new to you. Now, when we have the, the integral part and the decimal part. Now, in 75.69, online students use the emoji, raise your hand. Ariston, Aishwarya, Harsha, Shreya, Gayatri, Anantika. Very good. Very good. Okay. So now this, in this number, we say that 75 is the integral part. Integral part. Meaning it's an integer. Integral is of integers. Okay. What is floral? What is floral? Something related to flowers, right? Floral design. You must have learned in science, no? Flora and fauna.
Yes, ma'am.
Flora and fauna. Meaning flora is plants and fauna is animals, right? I'm not a student of science. I don't know. I'm just trying to recall from what my teacher told me when I was young. Flora, I'm not misleading you, right? Flora is plants and fauna is
No,
animals.
ma'am, you're right.
Yeah.
Yeah, ma'am.
So floral is of flowers. Floral, meaning of flowers. So similarly, integral part, meaning of integers. Integers. Integral, integers. So this is the integral part and this is the decimal part. This is the decimal part. Now the grouping, the way we pair the digits differ here. Let me take a different number to explain that. For example, yeah.
Ma'am, I have a question.
Yeah.
Is the long division method easier or the prime factorization easier, ma'am?
Both are easy to understand, but if you talk in terms of time, so the long
Yeah.
division method will give you the answer in lesser time when compared to the prime factorization method.
Okay, ma'am.
Yeah. Okay, so now how do we pair the digits? That's very important. Now in the integral part, we pair it from behind, like 95, 83, 1 stands alone. But in the decimal, see, in the integral part, we pair it backwards like this, 95, 83 and 1 stands alone. But in the decimal part, we go forwards like this, 49, 69. We go forwards like this. See, the way we pair the digits is different in the integral part and in the decimal part. In the decimal part, we work backward. That is, we come from the units place. Units, tens, hundreds, thousand, 10,000, we come from behind. So units and tens make a pair. Hundreds and thousands make a pair. And 10,000, the digit in the 10,000 place stands alone. But here, what is the place value here? What is the place value here? That's not important for this answer. I'm just asking you. Tens. Or 1 by 10. This is hundreds. Hundreds or 1 by 100. This is 1 by 1000. This is 1 by 10,000. The place value. I said 9 here, right? See, this one is this is 10 to the power 0. This is 10 to the power 1, which is 10. This is 10 square hundreds place, 10 cube thousands place, 10 to the power 4, 10,000 place. This one is 1 by 10, 1 by 100, 1 by 1000, 1 by 10,000, and so on. This is 1, no? So 10 to the power 0. 1 means 10 to the power 0. Anything raised to the power 0 is 1. So 10 to the power 0, this one is 1's place. This is a 10's place, 10 to the power 1. 10 square is 100, so 100's place. 10 cubed is 1000, 1000's place. 10 to the power 4, 10,000. Okay, now coming to this question. 18395.4969. So we group like this in the integral part and forwards like this in the decimal part. Integral part, we group backwards, like this backwards. But in the decimal part, we group forwards. We move forwards and pair the digits. Now, 1 stands alone. So it is 1, 1's a 1, or 1, 1 is 1. 0 is the remainder. Then the next pair comes down. Correct. The next pair comes down. Next, double the quotient. 1 into 2, 2. Then whatever digit we place here, we need to place the same digit here. So what can it be? Tell me. All of you think. Quick, quick. Ariston.
Yes, ma'am.
Yeah, you can answer even if I don't ask you. The question is for the class.
Yeah.
And you are a part of the class. So you normally tend to answer only if I specifically ask you. But remember, you can participate. The question is for the class. So you can answer.
Okay, ma'am. 1 second.
Okay, I already got it from a student here in the class.
Is it
23.
9, ma'am?
No. 23 into 3. Whatever digit you place here, you must place the same digit here. So it's 23 into 3. Because 24 into 4 is 96, which is way more than 83. So 23 into 3, which is 69. What's the remainder? Why no participation from online students?
Mom, actually, this method I'm slightly confused. Can you explain it again after you're done with it? Like explaining it first time.
Okay, 1 minute. 1 minute. Let me do it now. Sorry. Yeah. You understand how we group, Anantika?
Yeah, ma'am. From like, yes, ma'am, I understood.
Okay. Okay, now I think if you can share your thoughts, it will be better for me to help. Tell me. One into 1, 1. Is that fine?
Yes, ma'am.
Remainder?
0.
Next pair comes down. Is that fine?
Yeah.
Double the quotient.
Yes. So 1 plus 1, 2.
Okay, so 2 here. 1 plus 1, 2, or double it. So into 2. Whatever is there into 2. So 2. Now, so where should you place the 2? Beside this one, beside this 83. All right. Don't go very close to the margin. Just place it a little away from the margin. Now, Whatever digit you place here, you must place the same digit here. Is that fine?
Yeah.
Now, if you place 2 here, you must place the same digit here. Then the product will be 22 into 2.
Yeah.
If you write 3 here, then it'll be 3 here also. So 23 into 3.
Yes.
If it's 4 here, then it is 4 here also. So 24 into 4. So using digits, placing digits like this, you must find the product which is equal to 83 or just less than 83. So when you work 23 into 23 and 24 into, 23 into 3 and 24 into 4. 24 into 4 is 96. This one is 69. So we'll go with 23 into 3, right? Where are you, Anintika?
I'm here.
Yeah, please acknowledge. I said 23 into 3 is 69.
Yeah. Yes.
So you need to place 3 here and 3 here. It's not 23 into 13. It is not 23 into 13. It is 23 into 3.
It's the same way we generally do, but I'm confused with the arrows.
No, arrows only to pair. Arrows have got
but
nothing.
why is one pointing to the left and another to the right?
Okay, then don't do it. Don't show the arrows. I was just trying to show the direction in which we group. Here in the integral part, we group from behind like this.
Okay.
In the decimal part, we group it forwards like this. The arrows you don't have to indicate. You can just place a bar to show the pair. You don't have to show the arrows.
Yeah.
I use the arrowhead to show the direction. That's all.
Yes, understood.
So 23 into 3 is 69. Next what? What's the remainder? 14 is the remainder.
14, ma'am.
Okay. Now, Anantika, what do you have? This is called a partial quotient. This is called a partial quotient. That's not the quotient fully. That's a partial quotient. But every time I will not say partial quotient, partial quotient. I'll just say quotient. So what do you have in the quotient? 13. Double it.
Yes.
Double the quotient. All right. So place a digit, place the number here. Beside 14, place it here. Now again, whatever digit you place here, you must place the same digit here. Of course, you'll have to bring the next pair down. I forgot that after the remainder, children immediately bring the next pair down. After the remainder, 14, bring the next pair down, 95. Then double the quotient, 26. Now tell me, what is it? 5. Okay. So Lakshana says 5. So if you place 5 here, you must place the same digit here, 5. And how will you find the product? It is 265 into 5, not 135. It's 265 into 5. What's the product? 1325. 1325. This is the closest product. This is the product which is just less than 1495. I'm concerned if I'm clear to Anantika.
Ma'am, it is clear to me. I am now able to understand.
Okay, now find the difference. I'll tell you, I haven't come there. I'll tell you. Now, what's the difference, Lakshana?
170, ma'am.
170.
170.
170. So after you get the remainder, bring the next pair down. But listen to me. The next pair has to come down, which is after the next pair which has to come down is after the decimal point. So you need to place a decimal point in the quotient here and then bring the next pair down. Is that okay? 49 is the next pair that has to come down, which is after the decimal point. So place a decimal point in the quotient and then bring the next pair 49 down. Now continue the same procedure. Double the quotient. 135 into 2. Double the quotient. 270. Place it here. Place it beside this. 270. Again, whatever digit you place here, you must place the same digit here and get the product which is just less than 17049. Or maybe equal to that also. Tell me. I want the answer from Anantika. Others do not answer. Class is given. When any assignment is given, you must work on this paper. Only for assignment. Okay, whatever I share on WhatsApp as assignment, all that you should work on that. Anantika?
Yes, ma'am, 1 second.
Okay, okay. Not found, Anantika?
No, ma'am, I'm not getting it.
No, you need not get the number exactly. You need to find. Yeah.
Like
You-
the number just smaller than the.
Just smaller than that. Yes, yes,
Yeah.
yes. You may get the exact number also. If you're not getting it, you should find the number just smaller than the number 17,049. Okay, just tell me what are you working on, Anantika? Tell me what have you found? 270.
Ma'am, I'm
What is
trying to multiply it with like the dash that you put. I'm trying to use different numbers.
Now what is the what is the latest one you're doing? 270, and what's the digit you've taken?
Ma'am, 8.
8. Okay, so you're trying to find 2708 into
8.
2708 into
Ma'am, 8.
8.
But
Okay.
it's bigger.
So 2708 into 8. Yeah, it's bigger. So you'll have to try 2707 into 7. Try this.
Ma'am, I already tried that.
Yeah, what do you get?
Ma'am, I think. Oh, what I got? I got 1,800 and. Sorry, 18,949.
Correct. Yeah, then try 2706 into 6.
Ma'am, yes, ma'am, that is coming correct.
Okay, so let me know the
16235. 36, sorry.
Yeah, correct. So if you place a 6 here and a 6 here, 2706 into 6. What is the product you got, Anantika? 1.
Okay, so the 1 second. The product I got is 16236.
Very good. Find the difference.
Mom, can I see the
9
difference?
minus 6, 3, 4 minus 3, 1. Then 8. Yeah. 8, 1, 3.
Yeah, okay. What's the next step now, Anantika?
Now you bring down the second pair of numbers, 69.
Okay, is this the last stage of division?
Yeah.
Okay, and given that this is a perfect square, in the last step, you have to get 81369 as the product exactly.
Yeah.
Yeah. So what's the next step? Double the quotient.
So we get
Ignore the decimal point. Just take 1356 into 2. Ignore the decimal point. 1356 into 2.
yes, 1 second.
Ignore the decimal.
2712.
Yeah, 2712. Okay, 2712. I said ignore the decimal point. 1356. Just read the number as if there were no decimal point. 1356. Double it into 2. 2712. Now again, whatever digit you place here, you must place the same digit. I'm not able to annotate because okay. Whatever digit you place here, you must place the same digit here. And since it's the last stage and the units digit here is 9, what do you think can be the digit? 9. 3 3s are 9 or 7 7s are 49.
Yeah.
Yeah. So you need to try 27123 into 3 or 27127 into 7.
Ma'am,
Try
I'm getting it as 3 only. 27123. It's coming
into 3.
perfectly.
Okay, very good. Then it is 3. And that you get 181369 and the remainder is 0. I have no place, so please, the remainder is 0. So the square root is 135.63.
Mom, this is Aishwarya. So
Yes.
when we move on to the next part, we are supposed to multiply the quotient by 2, right, Mom?
Yeah. Ignoring the decimal point.
That if we actually add the recent number of the quotient.
Yeah, that also will give you. That also will give you. I'll tell you that also. Okay, fine. I'll tell you that.
Because I didn't know that we had to double it. So till that time, I was actually adding the last digit.
Yeah, you may have learned it like that in school or somewhere else. It's not, or did you figure that out by yourself?
Mom, I figured that out by myself.
That's great. Oh. Yeah, you can. Both the ways are fine. Adding is how we learned, but now teachers use this method. So I'll tell you that also. That's done, children. Okay. I'm not waiting because I was slow. So all of you had sufficient time to work it, right? Finished it?
Ma'am, I'm done, ma'am.
Yeah.
The answer is 8.7.
Oh, this one. No, I'm talking about this question. No, I'm talking about this, not 75.69.
Oh, okay, ma'am.
Yeah. Okay. So now coming back to the same thing, Aishwarya wants me to clarify on this. So what was the number, children? 18? 1? 1?
18395.4969.
Okay. Okay, let me just do it fast. So pair it like this. Okay, 1 is 1 0. Bring the next pair down. Now the other way, of explaining is this is instead of doubling the quotient, what is the digit here? 1. And there's because it's a single digit, there's only the units digit. Add it to itself like this. 1 plus 1, 1 plus 1, 2. Place that here. 2 here. Place that instead of doubling, you can also understand like this. Instead of doubling the quotient, 1 plus this digit in the ones place, which is 1 itself. 2. Now, whatever you place here, you must place here. What is it we got? 23 into 3, which is 69. And what was the remainder? 14. Correct? Bring the next pair down. So, bring the next pair down, meaning? Yeah. Has somebody come? Is it your mom? You can ask her to come and sit down. Or you want to go out and tell her? You can tell her. You can ask her to come to the class. Okay, so bring the next pair. I'll wait for you. Just a second, children. Yeah. Okay, so bring the next pair down. Bring the next pair down. So 9, 5 comes down, right? Now, what's the digit you have here in the ones place? 3, correct? You have 3 here. Add the digit which is in the units place. So plus 3. What do you get? 26. And that's what we get by doubling the quotient also. 13 into 2 is 26, right? Same thing. So add the digit in the ones place. So 26. Then again, whatever digit you place here, you must place the same digit here. And what was that? 5. So 265 into 5. What was the product? 1325. And the remainder? 170. 170. All right. Now, the next pair that comes down is after the decimal point. So you need to place a decimal point here and then bring the next pair down, right? Okay. So again, what is the digit in the ones place here? 5. Add that. Plus 5. Keep adding the digit in the ones place to get the next number. Or you can double the quotient. So add the digit only in the ones place. So 5. Add 5. 265 plus 5. 270. And that's what is 135 into 2 also. 135 into 2 is also 270. But you need to write it a little away from the margin. You need to write the sum a little away from the margin, 270. Because again, whatever digit you place here, you'll have to place the same digit here. And what was that? 6. What was the product? What was the product? 1? 236. Remainder? 8, 1, 3. Then the next pair comes down. The next pair comes down. So again, what is the digit in the ones place? 6. So add 6. Add 6. And that will give you 2, 1 carried over, 7, 2. And that's exactly 1, 3, 5, 6 into 2 also. You can do this also. This is also fine. But the sum you should write it a little away. You should not write 6 plus 6 or 12 here. Very close to the margin. Then you will not have space to write the digit here after this. So write it a little away. Leave space for that one digit which you need to place here near the margin. So Aishwarya, you're also right. You can also do that.
Okay.
Yeah. Now the prime factorization, I want you all to understand by yourself. The prime factorization method, you can see it here. I'll just explain how it works. Now the question is, the heading here is to find the square root of 75. The heading is to find the square root of, oh sorry, I think I've gone to the next one. Yeah. Find the square root of 75.69, right? 75.69. Okay, by the prime factorization method. Using the prime factorization method. Long division method, all of you understand now. See here. I have not specified which method. I have worked both the methods for you. So whatever is in the exam or test, if no method is specified, you can use any method. At school, if no method is specified, you can use any method. If specified, you have to use that method only. Okay, so I have done it using both the methods. So long division method is now simple for you. The prime factorization method. So you need to first, write the decimal number as a fraction. That's the first step. Step 1, write the decimal number as a fraction. All right. Now, find the prime factors of the numerator and the prime factors of the denominator. So now 75.69 is 7569 by 100, right? Okay, so this is what it is. Now, this is how you express 7569 as a product of its prime factors. And you can see the working here. See, nothing can be written just like that. Just looking at 7569, I cannot write this. I have to work this one. So it's done here. Okay, so you need to work this, you need to work this. So we understand that 7569 is 3 into 3 into 29 into 29. That's a numerator. And 100, see here, I've worked it here. 2 into 2 into 5 into 5. Okay, so first step, write the decimal number as a fraction. Take up that fraction, express the numerator. Express the numerator as a product of its primes. Express the denominator also as a product of its primes. That's the second step. Now, since we have to find the square root of the given number, take square root on both the sides. Taking square root on both the sides. All right. So taking square root on both. So basically, you need to repeat the step. Write the step again. Write the step again. Repeat the step and take square root on both the sides. Take square root on both the sides like this. All right. Now, in the next step, go back to the number which was given. Go back to the number. What is 75? Sorry, what is this number? Is the decimal? 75.69. Go back to that. Okay, go back to that. Go back to that. Correct? Go back to this one. But don't take away the square root symbol. That will remain. Is equal to here in the RHS, in the right hand side, in order to get rid of the square root symbol, from a pair of equal factors, we bring 1 out. So from 2 3s, 1 3 out. From 2 29s, 1 29 out. In the denominator, from 2 2s, 1 2 out, and 2 5s, 1 5 out. Now the square root of 75.69 is equal to 3 into 29 is 87. 2 into 5 is 10. Now 87 by 10 is 8.7. Don't, even if it was possible to simplify, don't simplify. Supposing like 5 ones are 5 5s are, supposing, don't simplify. Don't do that. Just multiply the numerators, multiply the denominators. Because whenever you have the denominator is 10, 100, 1000, it's easy to just place the decimal point, right? Otherwise, you'll have to do the division again. So 87 by 10, which is nothing but 8.7. Is the procedure understood, online students? Please acknowledge Aishwarya, Harsha, Anantika, Ariston, Gayatri, and Shreya.
Understood,
Yes,
ma'am.
ma'am. Clear, ma'am. Understood.
All right. So this is how we find the square root of a decimal number by the prime factorization method, and long division method is the same, except that when you bring the pair which is after the decimal point, you need to place the decimal point and then bring it down. That's the only difference. The rest is the same. When you bring the pair which is after the decimal point down, you need to place the decimal point on the quotient and then bring it down. Yeah. So I'm just sharing this image on WhatsApp. Please complete this. Leave some space in your classwork now. All of you have taken this question. Have you all taken this question, children? Please take down the question.
Yes, ma'am, I've taken the question, ma'am.
Yeah. So you can now judge the amount of space you need to complete this. Leave that space in your classwork. The picture is already there on WhatsApp. You can complete it later. Assignment should be done in the sheets. Yeah, now you should complete it there in this book.
On WhatsApp?
No. WhatsApp now I told you, that this is classwork. This image is classwork. If it's homework, there will be a message that it's the homework. Okay. This image is the classwork now. Okay. Yeah, this also is classwork, children. I'm not, we're not doing it now. I'll share the image. Please complete this also in the classwork notebook. Similar to the earlier one. So these two sums have to be completed in the classwork notebook. Leave some space now. Actually, you don't have to, because the rest of it also we're just going to understand. You are going to complete it later. So fine, no issues. Yeah, this is the next one. Is 6,000 a perfect square? Give reasons. Okay. Is 6,000 a perfect square? Give reasons. So you need to find the prime factors of 6,000 in using this procedure. Okay, so using this procedure, express 6,000 as a product of its prime factors. See, the question is not find the square root of. The question is the number a perfect square? Is 6,000 a perfect square? You don't have to, even if it is a perfect square, you don't have to find the square root. Is it a perfect square? If yes, give reasons. If no, give reasons. Okay, so first perform this procedure and express 6,000 as a product of its prime factors. So what do you see here? It is 2 square into 2 square into 3 into 5 square into 5.
Because they don't have an equal amount of time.
Very good, perfect. Because every prime factor does not have a pair, correct? So always write it to the power 2, children. Always write the prime factors to the power 2. Okay, so 6,000 is equal to 2 square into 2 square into 3 into 5 square into 5. Don't write 5 cubed. Don't write 5 cubed. Always raise the prime factor to the power 2. Maximum power you're going to give us 2 for this answer. Don't write 2 cubed, 3 to the power 5. No. Group in 2's. So it is 2 square into 2 square into 3 into 5 square into 5, not 5 cubed. So we see that the prime factor 3 and 5 do not occur in pairs. The prime factor 3 and 5 do not occur in pairs. Therefore, the given number is not a perfect square. Because if it's a perfect square, every prime factor should occur in pairs. If there's a 2, it should be 2 square. If there's a 3, it should be 3 square. If there's a 5, it should be 5 square. If there is a 7, it should be 7 square. But there is a 3, but it's not 3 square. If there is a 5, it's not 5 square. So you can write the reason in your own words, actually. You can write the reason in your own words, like whatever you understand. You can say that the prime factors 3 and 5 do not occur in pairs. You can give a simple reason like that. The prime factors 3 and 5 do not occur in pairs. Therefore, 6,000 is not a perfect square. It's not a perfect square.
Ma'am, it's not a perfect square since the 3 zeros are in the odd, right?
Sorry?
There are 3 zeros and the zeros are odd in number, so it's not a perfect square also.
Yeah, that's right. If it is for 1 mark, then you can answer it like you can just check that answer. But here you have to show the working and You're right, Ariston, because 6000 ends with odd number of zeros. It cannot be a perfect square. You're right, but that cannot be a reason here. For a question like this, which is not for 1 mark, you are expected to present it like this. All right.
Okay, ma'am.
Okay, so this is also, these images are classwork, children. You can write this reason or the reason I've given down. So since the reason you see here is since 6000 cannot be expressed as a product of pairs of equal prime factors. As a product is because this one as a product, this one product of pairs, you understand, 2, 2 of equal prime factors. Yeah, these are equal. See, 2 and 3 also makes a pair, right? 2 and 3 is also a pair. Is 2 a prime number? Yes. Is 3 a prime number? Yes. So 2 and 3 make a pair of prime numbers, right? But they're not equal primes.
They're not the same.
Yeah, that is why the word equal is important. As a product of pairs of equal prime factors. Because pairs of prime factors, see, 5 and 7, 5 into 7 is a pair of prime factors. 5 and 7 is a pair of prime factors. No, it's not that. Because 6000 cannot be expressed as a product. Product is its multiplication sign. Product of pairs of equal prime factors. It is not a perfect square. This is a general reason. Very specifically, I've given here. You can write this one. What I've mentioned here. You can write this. Please write this one. Okay. Next one is 32,400 a perfect square. So procedure is the same. Procedure is the same. And 2 square, 2 square, 3 square, 3 square, 5 squares. Every prime factor occurs in pairs. Therefore, it's a perfect square. Every prime factor occurs in pairs. Therefore, it's a perfect square. Right? Right? So this image is also online students. Is it fine? Online students, any questions?
Yes, that's clear, ma'am.
No, ma'am.
Okay. Yeah. Just 5 more minutes, children, because I need to share an assignment for which I need to complete 2 more sums, 3 more sums. Okay. I'll just need 5 minutes to explain that. Yeah, this is the next one. What is the least number? 5, 6, and 7 children, 3 more sums, just 5 minutes. I'll explain it and then you can complete your classwork as well. Complete the assignment which I have to share with you. So please bear with me for 5 more minutes. What is the question is, what is the least number by which? 1 second, children. Madam, auto then wait பண்ணிட்டு இருக்கேன். The question is, what is the least number by which 1176 is to be multiplied to make it a perfect square? So what do we understand from the question? The given number is not a perfect square. 1176 is not a perfect square. Like for example, 50 is not a perfect square. Now tell me the smallest number. This is a very, you can just guess it. Tell me the smallest number by which it has to be multiplied to make it a perfect square. 50 is not a perfect square. What is the smallest number by which it should be multiplied to? 15 twice 50. What is 15 to 2? 100. And is 100 a perfect square? So 50 is not a perfect square. 50 is not a perfect square. We need to multiply 50 by 2 to make it a perfect square. 50 is not a perfect square. To make 50 a perfect square, the least number by which it has to be multiplied is 2. 50 into 2 is 100 and 100 is a perfect square. So for a simple number like this, you can, meaning for a small number like this, you can guess. But what about for numbers like this? You cannot guess. So what is the procedure then? What is the procedure? So perform this procedure. Express the number as a product of the prime factor. So you get 2 square into 2 into 3 into 7 square. Correct? Now, which are the numbers that are not in pairs? See, if this number has to be a perfect square, it should have been 2 square and 3 square. It should have been 2 square and 3 square. Then what is missing? 1, 2 and 1, 3 is missing. So 2 into 3, 6 is the least number by which it has to be multiplied to make it a perfect square. Least number. You can multiply this one by many. See, now 50 can be multiplied by a different number also to make it a perfect square. Now, for example, 50 into 8. What is 50 into 8? 400. 400 is a perfect square. So 50 can be multiplied by different numbers to make it a perfect square. The number 50 can be multiplied with different numbers to make it a perfect square. But the smallest number is 2. In the same way, 1176 can be multiplied by different numbers to make the perfect square, but the smallest number is 6. The smallest number by which it should be multiplied is 6. And how do we figure out that? This one. This should have been at least 2 square. This should have been at least 3 square. Then how will 2 become 2 square? Another 2. How will 3 become 3 square? Another 3. So 6 is the least number by which it should be multiplied to make it a perfect square. Is it fine, online students?
Yes, ma'am.
Please acknowledge.
Yes, ma'am.
Yes, ma'am.
This is divided exactly the same procedure, whichever number. So now divided meaning there is 5, there is 11. But this shouldn't have existed at all. Divided means you should remove the, see when it is multiplied, then you need to include more factors. When it's multiplied, you need to include, you need 1 more 2 and 1 more 3. So 6. But when it is divided, you should take away the numbers that are not in pairs. When it is divided, simply take away the numbers that are not in pairs. This 5 and 11, they don't occur in pairs. Take it away. So 55 is the least number by which it should be divided to make it a perfect square. When it is divided, take away the primes that do not occur in pairs. 5 and 11 do not occur in pairs. There is only 1 5 and 1 11. They don't occur in pairs. So take it away. 5 into 11, 55. So 55 is the smallest number by which it should be divided. All right. All right. Online students.
I understood, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. Yeah, 1 more to go. 3 minutes for that. And we are done with today's session. The area of a square field is given to you. You need to find its side and perimeter. What's the formula to find the area of a square, children? Sorry. A into A square. Yeah, length into breadth is fine, but since it's a square, all the sides are equal. So supposing the side of the square is A units. Area of a square is given by A square. A square or side square, whatever. A square or side square or A square, correct? Area of a square is given by the formula A square or side square square units. So look at this one. Don't see the long division, children. Don't see the long division. Look at this one. What is the area of the field given? 1056.25 meters square. What do you mean by area of the field? Side square is equal to this one. Keep replacing. Don't see this one. See this one. Area of the field is given to be this one. Area is nothing but side square is equal to 1056.25. So if side square is this number, the side will be the square root of the number in the RHS. Like if a square is 25, then a will be equal to the square root of 25. They are inverse operations. Like when it is multiplication, it goes for division to the other side. If it is division, it goes for multiplication to the other side. If it is square on one side, it will become square root on the other side. If you take the square from one side and put it to the other side, it will become the square root. Like with addition on one side, on the other side it becomes subtraction, right? When you transpose. When you transpose, they take opposite operations. Correct? Plus becomes minus, multiplication becomes division, square, square root. So a side square is equal to this number. So the side will be, that is, you're kind of you're taking this to the other side. Well, side will be equal to the square root of 1056.25. So you know how to find the square root of 1056.25, correct? Correct? The long division method, we just understood that. So find out that. And so the side is 32.5 meters. The side is 32.5 meters. All right. Now the question is find its side. Yeah, we just found its side and find the perimeter. Perimeter is equal to 4 into side. Perimeter of a square is given by the formula 4 into side. So 4 into 32.5, which is 130 meters. So write on the, the value given. Area of the field is equal to 1056.25. That's given. Below area, write side square. Why? Because that's the formula to find the area, right? So side square is equal to 1056.25. Now you want to take the square to the other side. So it will become side is equal to the square root of 1056.25. Then find the square root using this process. See, till here you'll have to work. Then the square root, this method. Correct? Then you'll have to do this. What I have done is, I know we know that once you are familiar with this question, you know that you have to find the square root of this one, right? So you can already find it first. You can just find out the square root first and then you can work this. So side is equal to square root of this number, which is 32.5. Correct? So now perimeter, we found the side. Now perimeter is equal to 4 into side, which is 130 meters. Is this understood? All right. So children, all this classwork, please complete it in the notebook. All right. And then I'll share the assignment. This is the assignment. Okay, let me share the image. Don't get confused, children. The images with the answers are a part of today's classwork. The image without any answer, only question you see, that is the assignment. Yeah, without performing that, how will you get 32.5? Correct? The images with the answer are classwork. Please complete in the classwork. And offline students, assignment has to be done in the long rule sheet which I've provided to you now in the class. Yeah, this is the assignment, children. Okay. Everything is sent on WhatsApp. You can find all the images on WhatsApp, children. Online students, use the emoji, raise your hand. Gayatri, are you there? Aishwarya, Anantika, Ariston, Shreya, Harshan, Gayatri, are you there? Okay, good. All right, children.
Yes, ma'am.
All right, children. So, yeah. All right, children. So that's it for today's session. Thank you so much. You may leave the call. Good night. Thank you, children. Good night.
Thank you, ma'am.
Thank you, children. Good night.